Hello everyone, welcome back to my series about creating an HTTP server, implementing an HTTP server from scratch in Golang. This is part 4 of our series. Last time we were able to build a response builder, and I would suggest we just look at the current state of our server. Let me start the server quick. So if we call localhost port 8080, so the address of our server in our browser, we see that we are able to accept the connection, pass the request, extract the method, the path, the version, the headers, and form a response, which for now contains hello world, and the response is a valid HTTP response and can be read by the browser. Perfect. The goal for this episode would be to implement a router to be able to handle various paths like users or like admin, because right now the response is always the same, and the response should depend on the path we call. And I have some thoughts about how we approach this, because for sure we could like implement a enum and then have a switch statement on this enum, and because we extract the path, and then we could check like is it this, is it that, and then call a function in a switch statement, just would be a quite default way. But the disadvantage is that we could not programmatically add another route, because we had to like code it in add a route on the enum and then the switch statement. But what I would like to do instead is have a new structure or new handler, router.go, which is in the package model. Doesn't quite fit actually, but let's not care about structure. And my thoughts were that we have like a router struct, which is public, of course. And this struct would contain known paths or something, which would be a map of type. Yes, of which type actually? Key would be path, and value, and this we will probably have to Google actually. Go map value function pointer. I would like to be the value to be a function pointer pointing to the function that handles this path, because then we can have a function to add a route later on in like a web UI, if the browser has a web UI, or this could be a framework, and someone just calls our integrates our packages and then just needs to call this add function if the person wants to add a new endpoint. How to get a pointer to a value in a map in Go. That's not actually quite what I want. Passing values and pointers in Go function. Go function pointer. I think that's. Can we have function pointers in go. Yes, that's quite what we are looking for. It works if you're using the signature. There's no pointer. Function say hello, var, hello function, hello func, and hello func is of type func string. Then we assign say hello to this variable. Then we just call it. I think that looks good actually. So let me have a quick thinking. I think we could just do we always have the same parameter? I think we must have. So the function that handles our request probably needs just a full request item because there's everything in it. Yes, that sounds very good. Okay. And so we define, let's define here, type, let's call it router func. And it's a function that takes it's in the same, that takes a pointer of an HTTP request. And the value is a router func. Nice. Does our router need anything else actually? I don't think so. Okay, then we have a function, new router, does not need any arguments, and returns a pointer to a router. Then we return the address of router. Make. Yes. Perfect. So we have an empty map. Oopsie. So we have an empty map. Perfect. Then let's append a function, add path. We need to provide a path here, and I don't think we need to return value. We need to return value of an error type because someone could give us a path that already exists in our router, in our known paths. And if so, we should check, right? We say var error if how do we check if something is if a key exists in the map? If known r.known path at path is equal to null, I guess this way, then we would say errors new error adding new path already exists. Yes, I think that's good, right? In this case, we just return error, actually. If not, we would like to add it. So actually, the add path function needs one more thing, and that is a router func. Handler. Let's call it handler. Because we need to path to also add it to our map, obviously. And in this case, our dot non-paths at the key path would equal our handler. And then we return null, because there's no error, except this crashes. Perfect. Then we would also need a function to delete path. In this case, we just need a string. Do we need an error here? I would give an error if the path provided does not exist, but if it does not exist, the user would think, hey, this path exists and I want to delete it. So the user expects that the path does not exist after calling this function. And if it does not exist before that, then there's no problem, right? We probably should check though. If to not crash the program. But we could check this way, right? Again, this is nil. Then we just return actually. In any other case, yes, how do you remove actually, how do you remove a key value pair from, because for example, we don't only want to remove the value. So if we just say this equals nil, then there's no handler pointer anymore, but the path still exists. That's would not be too good for us. So go map remove key. Delete key in map. That sounds good. I have a map. Yes. Okay. How do I delete sessions key? I tried null false. Okay. That didn't work. Go introduce delete. Well, sometimes it's that easy. Delete. Our map is called unknown paths and the key is path. Then we can return. Which we don't need to actually. It's obsolete because it's the last line of the function and it returns automatically anyways. Okay, there's just one more thing for us, I think. And that is to learn how to create a variable with a function in it to be able to path it to our add path method. There's one more actually, which would be useful, and that is a handle path function. That is the case. If you get a request and we want to actually do something. So in this case, we need the request. Probably have an error here. And always check for the path, I would say. But Actually, we only check for if the value at the key is not nil, but maybe let's say go map check key exists. Maybe the key does not even exist. Next Stack Overflow. Okay. We just have to, the value is clear and then the okay is a bool. If the key exists, it's true. Okay, do we need a value here? That's the function pointer. Yes, I would say we need it here. So we could say var. No, we actually say handler, and the other was okay, equals to, oh, no new router. Add this key. Yes. And then we can say if not okay, error equals errors, new error handling. Can we format this? Or do we just say concatenate error handling path? New line. And then path does not exist. I have an idea. Because this case, if a path does not exist, is actually exactly the case. Our server should return a status code of 404 because the requested resource does not exist. So do we actually return an error here or an integer? We return an integer here. Nice. That's cool. Let's say var status code int. If okay, status code equals 404. In any other case, we would like to call our handler with our request as an argument. Then set the status code to, let's say, 200 for now, because then everything is okay. It's a success. And then we return the status code. Yes, that looks more clean to me. I would like to change some stuff here, and this is okay. Here we don't need the value, but we need the okay parameter. If okay, and then we check if the does not exist. That's actually a quite useful way in Go to have a variable in this only in the scope of the if statement. Maybe only in this if tile, if region and not inside of the statement. I'm not quite sure about that. Let's check. Can we access okay here? Yes, we can. Okay. And then we can add another statement for the actual if part. But that's quite useful. And we will do the same here. We'd say okay, and then ask known partners, part, and then we check if not okay. Then there's an error. Here the error is right, and we want the error. Okay, the handler means we just call our handler function, and this does everything we need, right? For now, I think that's okay, or is it? Because at the end of the video, we will want also be able to respond depending on the path requested. This means this handler function probably wants to form a response actually. So the router would also build the response. Is that clean? Probably not. But I don't care. How do we add a... Actually, how do we add a return value? Can we just say response? Our response is a string, right? Yes, yes, yes. String. Can we say string? We can. That's perfect. Then we say response. In this case, we will return not an integer, but say a pointer to a string. That's not too good. Fuck. Maybe the response should be a struct, because now we would add the status code inside of our response string, which is not quite the way we want to have it, because then we would have to pass the string again to check for the status code, which is not clean at all. So this little code here needs to change actually. We will need a HTTP response struct here containing the, what do we need? Let's say the status code integer. That's what we need for the status line. All right, we need then the reason phrase, just type string. We need that for the maybe let's say we have the version here as well, then we don't need to pass the request anymore instead of a response. Yes, then we need our, call it body. There's this bit here. Okay. Then we in our router will build this kind of response. And this function will be renamed to build response string. Yes, that's okay. And here we now no longer expect a string and the request, because the only thing we extracted from the request so far was the version. Okay, yes, we have this now. So here we actually expect a response now. And then we can access the version here for the status line. Or let's actually pass the whole response struct to this function, because we need the response dot status code here. We need the response dot reason phrase here, and we also need the response dot version here. Yes, looks good. Perfect. And then status line is a string now. Perfect. Build status line string. We should probably call the function now. Yes, I think that's more clean. String. Then we here we can just pass the response.body, because that's all we need. We just need a string for this. And the body itself will obviously be the body as well. Why is there an error? New. Ah, okay. Yes, obviously. Response string. And we return the response string here. Okay, now we obviously have an error. Should have an error in our main as well. But we first go back to the router. We have this. Now let's open this to did not notice. Help. Control and this key opens our changes. Okay, interesting. But what I wanted to do is to move this over here. Then we can go here and say router. Perfect. Because what do we do now? We expect our router func to no longer just return a string, but actually a pointer to a response struct. Or do we? No, let's expect a string. Okay, I'm intrigued. If we expect a struct, we could check for the status code and return it here, which we don't want to do. Maybe this function, actually, what we will do here, we expect the response struct, check for the status code, and build a, we built here we built a, yes, what do we build here? Okay. Okay. What do we want this function to return? The string. We want this function to return a string, so our main can only focus on returning the response to the client, no matter what's in it. Perfect. We have a handler function for our request. But in this function, we can already check if the status code is valid. This handler function can actually just provide the body. Right? And we build the response here. Build the response. And after that, we return the response string. So we have a var response string, type string. We have a var response of type HTTP response pointer. Not okay, status code, and we need a variable of reason phrase, also type string. Then, what's the official reason code for status code for reason phrase? Not found. Ah, yes, okay. My bad. Could have known that. Not found. Let's keep it lowercase, doesn't matter, right? Then we build a response. Let's say our response dot status code equals actually response dot status code. Probably this way, right? Response dot reason phrase. And then we just return. Okay, let's set the version always appropriate to the version. And the body would be empty. Then in this case, we want to be the response string, call build response string with our response. And then we can return our response string. Perfect. And if we know the part, we need to call the handler. The handler gives us where is the type? Gives us a string, which is the body. Yes, perfect. Status code will be 200. Reason phrase will be okay. This is all uppercase, but okay, never mind. The version is clear. So then we can assign these things. Response. I mean, it will work I'm not quite sure if it is the most clean way. So I'm not too sure about the way which function handles which assignment, because this function is called handle path, and we have a handler function for the request which knows what to do with the request. But this can be capsulated entirely from the logic of a web server, and this way we implement it right now, and I think that's good. So someone using this, let's call it framework, it's obviously no full working framework. Someone using it can just add a handler function, which could also be part of a desktop application, which has just business logic in it, right? Yes, that sounds very good to me. Because the string of our request body could also be in JSON format, and this function can knows what format it expects, and later on it would also need to return us a status code, I think, for like server internal errors, or for bad request and stuff like that. So we would not only return the body, but I don't think we need that right now. Yes. Then we assign the version of our request. And we assign our new body. Then our response string will be the result of this function call, and then we can return it here. Oh, I did not want to open the AI chatbot interface. Why are you null the reference and field selection? Oh, this could be a problem. Why is this a null? Because we should probably do this. And then we just dereference it here. Yes, that looks clean. Perfect. Now we can go back into our main.go. And what we want to do is change this bit here. So our data is depending on a whole lot now. We need a router. We want to add, let's say two paths, and then with a different response string in it. So we need two handler functions, and then we can test it, and also can test if for works. So we just will call use a path that does not exist in our router. But first, we are at 39 minutes of recording. I think I will take a quick break and have breakfast because it's in the morning here. And after that, I will continue. So see you soon. Hello, welcome back. So, we want to integrate our router into our main function here. First of all, will change. So the data is now handled in the handler function, so you don't need it here. We will need a router here. Router, new router. Perfect. Yes, perfect. Okay. Then we need, for now, we need to add a new, routes or a new path. First question, do we just keep the slash in the path? I think though, yes, it's easier. Then we need a func that takes in a request. What is the error here? Missing return. Yes. What exactly do we return? Once again, a string. Okay, why did we want to return a string again? Ah, the body. Yes. All right. I get. Okay. So in the home path, just a slash, we can return hello world, I would say. And then we want to add another path of, say, users. And here I return like a user value pair mock. User one is me. Then we create a new line and say user two other user. Yes, perfect. Okay. I think that's good enough to okay, we build currently. Actually, we should move this because we do this here at every connection we accept, but initialize router here is better. Building the response. And then model dot handle route, right? Yes, obviously we need the router handle route. This takes in our path, our request.path, and our, that was stupid. This only takes in the request, obviously, because the request contains the path. We don't need it as an extra parameter then. Because here we can say request.path. Okay. We handle the 404 inside this function. Okay, we only want a reference here. That's good. That's it, right? wasn't that much actually. I would suggest we just test it. We have no errors. So we say go run main.go. Okay, we're ready to accept connections. Quite intrigued to see if it works actually. Not really. Response for not found. Contact length. Send back an error for not found. Why is the empty path not found? We add the path here. And let's go into this. Obviously, this variable equals to false. Let's just check though. Log print line printf key path exists, and then what is the format specifier for a boolean? Okay. Maybe. Then we call F5. Why does the path does not exist? I mean, you can see that the path is the forward slash. Check again. We have like typo on our main function. No. So is there something wrong with our add path function? What could be wrong, actually? Let's check for an error here. Add error log print f adding slash, then string add error. Let's see if there's an error adding. Error adding new path already exists. That is kind of weird. But how would it exist? Maybe this expression wasn't working. Still the same error, okay. That is interesting. It returns true. Oh, yes. Yes, 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 yes. This returns true if the path exists, and we checked if it was false, meaning if it does not exist, we say error, which is quite stupid. Perfect. I think we found the error. Would be surprised to see it does not work. A segmentation violation. Runtime error. Invalid memory address or null pointer dereference. Main line 32. 33, sorry. Okay, we get an error here. We do not yet use this function, so um let's just comment this. But why wasn't it? Oh, that was the wrong file. I was wondering why does the error occur now, but it does not occur in this file. It occurs in main.go line 33, which is trying to print an error that does no longer exist. So let's remove this. And then we should be able to run the server again, correct? Nice. It works. So the test would be if slash users yields another result, and it does. And now if we say slash admin, for example, which does not exist in our server, we get an error for not found. That is the goal of the episode. Perfect. In under an hour. Nice. And there's only one thing that's not that nice is this should be a valid response, even with an empty body. And I would have thought that the browser can detect the status code of 404. Let's inspect it in our network tab. 404, okay. And I thought there's some like standard cool screen that gets printed if or displayed if there is an error like that, known error like that. But let's check. Let's go to the handle route function, handle path function, sorry. And maybe do not return an empty error. Not found as a body as well. And then let's run it again. Yes, 404 not found. Perfect. Now we could actually not only send like the body as a string, but we could respond with a resource, a picture, for example, because they are quite for pictures. There are some websites that use like custom pictures for we could use that as well. But for now, we're good to go with what we have right now. Nice. All right. I think that's the goal of the episode. We now have built a router. We can add routes. We did not check if we actually can delete them, but never mind. And then our next task actually for next episode would be to implement concurrency, to have to outsource the handling of the request, so the pathing and actually handling and the response in a different thread every time. Yes. So I will see you in the next episode. Have a great time. I hope you learned something new. I did. And yes, see you.